G'day, this video is just on a few little Year 10 harder area questions here. Okay, so just some more difficult ones. They're not overly, it's just probably a couple more formulas to plug numbers into. That's all measurement is really. You get the formula, figure it out, and do that. Just a couple of extra ones. The formula for the area of an ellipse. Poorly drawn. Basically, if you have an ellipse like such, and you have a small radius of this and a large radius of this, so you've got sort of, you call it a minor arc, minor radius and a large radius like that, and if you've got them as A and B, then your area will be equal to pi A B. Okay, pi times A times B, and it's as easy as that. Pretty good there. The other one is a triangle. Now, all we've done really so far is triangles where we know the base and the height. And this this formula here gives you a formula that tells you if you don't know the base and the height, that what you could do. So let's say that this is 7, 5, and 9 there. Okay. Let's just start with the formula first before we go an example. So let's just say you only know the three sides of a triangle. Then what the area of this triangle will be is equal to this. And it will look intimidating, but don't be. Square root of, you'll notice it's big. S minus A, S minus B, S minus C. That's the area of this triangle, where S is the semi-perimeter. Semi means half, so semi-perimeter is just half of your perimeter. The perimeter here is A plus B plus C, so you just divide that by 2 to get the semi-perimeter. And this is called Herons' formula. Okay, so just put a box around this. Quite important, it gets you out of many sticky spaces, because you don't always have a triangle where you know the base and the height. In this situation, if you had three sides, you don't know what the height of this triangle, you don't know what that is. So you can't use half base times height. This is Herons' formula, it gives you the answer in a different way. So they're pretty simple, they're the only sort of additions in Year 10 for measurement. And so let's just do a couple of examples of those, but I think you'll find it pretty good. So an example, find the area of, let's just go straight to something like this. Okay, so this is 12 centimeters, and that is 13 centimeters. Okay, so it's half an ellipse, this one, and we need to find the area of this guy. So, what is it? Well, it is an ellipse. In fact, it's half an ellipse. So the area will be half of an ellipse, which is half times pi times A times B. In this case, what's A and what's B? Well, if you think of this as the center of the ellipse, then that's the long side and that's the short side sort of there. And so what's A equal to? Well, A will be equal to that little distance there, which is half of 12, which is 6. And B will be this distance from here to here, which is 13. Too easy. So the area is going to be half times pi times A times B. Chuck it in your calculator. In fact, I'm just going to do this in my head, cannot be bothered. So half of 6 is 3. 3 times 13 is 39. So that's just going to be 39 pi. There we go. It's 39 pi. I'm going to leave it in Year 10 form because we're doing Year 10. So let's just say 39 pi, and it's going to be centimeters squared because we're doing area. Okay, fantastic. Now, if the question said find something like this, find the area to 1 decimal place or something like that, then you would have to not leave it like that. You'd have to put that into your calculator, equals blah blah blah, and you put your decimal in there. Okay, find the area to 1 decimal place. If it doesn't ask, put it as 39 pi centimeters squared. Too easy. Let's do Heron's formula question. These are quite good. He says, right, example. Right, some sort of triangle. I do that every time. I just can't sort of seem to. There we go. 5, 7, and 9. Say something like that. Got some triangle. We don't know this height in here. We can't use the formula area equals half base times height. It doesn't work. We don't know the height. But what we do know is the 3 sides. So Heron's formula tells us the area is equal to the square root of S minus A, S minus B, S minus C. So, and let's just write down what we know. A is equal to 5, B is equal to 7, C is equal to 9. It doesn't matter which order you do this in, by the way. B could be 5, A could be that, whatever. It doesn't matter which one's which. Our semi-perimeter is equal to, we just add them all up. Should have left myself a bit more space here, but it's 5 plus 7 plus 9, so that's the perimeter. It's the semi-perimeter, you divide by 2. So that's 5 plus 7 is 12, 12 plus 9 is 21, 21 divided by 2 is 11.5. So there's your semi-perimeter S. So let's go. Let's put that into a massive long thing. So that's equal to 11.5 times 11.5 minus A is 5, times 11.5 minus B is 7. It's just all your differences between S and each side, and then minus 9, like that. Okay, I'll just go one more step and then I'll put it into the calculator. That's 11.5 times by 11.5 minus 5 is 6.5, times by 11.5 minus 7 is 4.5, times by 11.5 minus that is 2.5. Put this all into a calculator. Alright. So we'll do this. I'm going to forget it though. 11, 6, 4, 2. So square root. So second square gives us that, and then we've got 11.5 times 6.5 times 4.5 times 2.5. Enter. Gives us a grand total of 28.99. We'll round that up to 29 even. Okay, so that's just equal to 29 and 29, and we haven't been given units here because I was lazy, and so the area is just 29 units squared in there. And that's Heron's formula. Nice and simple. Well, it's not simple. If you know what you're doing, know what S is, it's just a matter of plugging all those numbers into your calculator. And there you go.